Hi folks, we're going to solve number 9 on the Unit 5 assignment. So they're asking us to solve this equation on the interval negative 2 pi to 2 pi. So first thing, I notice the input of 3x here, but that's not worrying me because both trig expressions in my equation have an input of 3x, so I'm just going to leave it as is. But I do notice different trig expressions in the equation, and more often than not, I would like to have the same one throughout. And that can be easily done by just using our Pythagorean identity to change sine squared into 1 minus cos squared. All right, so we'll do that first here. So 2 cos 3x plus, and I'm just going to change this to 1 minus cos squared 3x equals 1. All right, and now I end up with a quadratic trigonometric equation, which I know how to solve. So I prefer having my leading coefficient being positive, so I'm just going to move everything to the other side of the equation. So this negative cos squared 3x is going to become positive cos squared 3x. Bring that to the other side, it'll be minus 2 cos 3x. And then here, when I bring the 1 to the other side, 1 minus 1 is 0. So that actually works out pretty nice because I don't have to work with a trinomial. I can just use a common factor here. So I'll do that. I'll take out the common factor of cos 3x. And what are we left with? We're left with cos 3x from the first term, and this we're just going to be left with minus 2. And so now we have it in factored form equaling 0, which is good because I can now say that cos 3x has to be equal to 0 or cos 3x has to be equal to 2. All right? So now I have what I want, an individual trig ratio equal to some number. Now I notice that second one here, hopefully you recognize that cos 3x can never be equal to 2 because it can't be equal to anything greater than 1. So right off the bat, I can just eliminate that branch of the solution. All right, now even if I did try to take cos inverse of 2, the calculator would tell me that I'd made an error. So I'm just left with solving this equation here. And of course, cos equaling 0 corresponds to a special angle. So remember, where cosine is x over r, so I just need to look for where x is equal to 0, which of course is on the y-axis. All right, so my two solutions here are going to be pi over 2 and 3 pi over 2. And while I'm at it, since I know it's going to be necessary, let me calculate my period here. So since my k value is equal to 3, the period of this expression is 2 pi over 3. I know I'm going to need that later on. All right, so based on what we just determined here, we know that 3x can be equal to either pi over 2 or 3 pi over 2. In other words, x is equal to pi over 6 or 3 pi over 6. And 3 pi over 6 is just pi over 2. All right, so these are my two basic answers, and I'm just going to be adding or subtracting the period of 2 pi over 3. All right, now, as I'm adding and subtracting to pi over 6, all right, I'm going to be thinking of this as not 2 pi over 3, but as, 4 pi over 6. Plus or minus that. This is what I'm going to be adding and subtracting from that first answer. And similarly here, I'm going to be thinking of this as 3 pi over 6 plus or minus multiples of 4 pi over 6. Okay? Okay, so again, good trick to always work with the same denominator. So let's start making the list of our answers here. All right? So x can be equal to, and remember that we're going from negative 2 pi to 2 pi, so we will have to add and subtract that period. All right, so let's start with the first set of answers. So I'm going to start with pi over 6. All right, the next answer will be pi over 6 plus 4 pi over 6, so that's going to give me 5 pi over 6. All right, let's add another 4 pi over 6, so that's going to be 9 pi over 6, but of course 9 pi over 6 simplifies to 3 pi over 2. And if I try to keep going, 9 pi over 6 plus 4 pi over 6 is going to give me 13 pi over 6. That's too big because that's bigger than 2 pi, so I'm not taking that one there. So my answers here are pi over 6, 5 pi over 6, and 3 pi over 2, since we should give it in simplified form. All right, but of course we also have some negative answers. So now I'm going to take this pi over 6 and I'm going to start subtracting the period. So pi minus 4 pi is negative 3 pi over 6, which of course is just negative pi over 2. All right, so negative 3 minus 4 is going to be negative 7 pi over 6. All right, and then negative 7 minus another 4 is going to be negative 11 pi over 6. And clearly I'm not going to go any further because then I'm going to get to something below negative 2 pi. All right, so I've got, in the end, 6 answers in all that come from this first base answer. All right, so now let's start working with the pi over 2. Okay, so we have pi over 2. Okay, but I'm going to think of this as 3 pi over 6, and I'm going to start adding the periods. So 3 plus 4 is 7 pi over 6. All right, and then here we've got 7 plus another 4 is going to be 11 pi over 6. All right, so there's 3 answers. Clearly, if I add another 4 pi over 6, I'm going to go over 2 pi, which I don't want. And now let's start subtracting. Let's do 3 pi over 6 minus 4 pi over 6, which is just going to be negative pi over 6. Okay. And here we've got negative 1 minus another 4 is going to be minus 5 pi over 6. All right. And then subtract another 4, it's going to be negative 9 pi over 6, which of course is equal to negative 3 pi over 2. And if I subtract another 4 from here, negative 13 pi over 6 is going to be too small because that's going to go below negative 2 pi. So in the end here, we have 3, 6, 9, 12 answers that all come from this little equation, cos 3x equal to 0. All right, so let's do a recap. Step number 1 was to recognize that I could change sine squared 3x into 1 minus cos squared 3x so that I can get an equation that was solely in terms of cosine. From there, I realized that I had a quadratic equation that could be solved via a simple common factoring. I also noticed that one of the branches of that factorization did not produce any answers, and so I was left with working with cos 3x equals 0, for which I used my special angles and the fact that the period was given by 2 pi over 3. And from there, I was able to generate all the answers. All right, so let's take a look. If you wanted to check this on Desmos, so what I would do is I would bring this to the other side, so I have 0 on one side of the equation. On a graph, it's always a little easier to read the zeros. Okay, so that's what I did here. I just plotted the function, and now we can start reading off our answers. So here we have, we can look at them. There's pi over 6, there's pi over 2, there's 5 pi over 6, there's 7 pi over 6, there's 3 pi over 2, 11 pi over 6, so all those answers that we got. And then similarly in the negative portion, we ended up with all these answers. So negative pi over 6, it's there somewhere. There we go. We have negative pi over 2, which is there somewhere, and so on and so forth. All right, that's it for this one.